Okay, so you should have this worksheet now. This is the uh, vertical problems worksheet, and I'm going to work through the front page of this with you. So here's the front page. We're going to work through 1, 2, 3, and 4. This video, I'm going to focus only on 1 and 2, and then I'll make another video for 3 and 4. All right, so 1 and 2, we're dealing with a stopper on a string. So we've got a 40-gram stopper. It's twirled on a 40-centimeter string in a vertical circle with a velocity of 2.50 meters per second. So A, B, C, D here, we're supposed to calculate the centripetal force exerted on the stopper, the weight of the stopper, tension of the string at the top of the swing, and the tension of the string at the bottom of the swing. Okay, so if we come over here and we start working out here, working this out, so we got 40 grams. First thing we need to do, convert that to kilograms. All right, it's a 40-centimeter circle, so that means that's 0.4 meters. Make sure we're getting that taken care of. And they gave us a velocity. This would be our straight line velocity, or tangential velocity, as 2.0 meters per second. So the first thing they want us to do, and we'll just go back and look at it real quick, is they want to know the centripetal force and the weight of the stopper. So we don't even need to draw a free body diagram for these. So let's just jump into it. The centripetal force, right, is just the mass times the centripetal acceleration. Well, in this case, that's just mass times v squared over r. So if we just punch that in, we got 0.04 times 2.50 squared over 0.4. Now, let me run this through the calculator real quick. And we get 0.04 times 2.5. And we get a centripetal force of 0.625 newtons. All right, so the centripetal force will always equal 0.625 newtons, no matter where it's at in the circle, because we're always going that velocity. Okay, next they want to know the weight. Well, weight, weight is easy. That's just Fg equals mg, because the weight is the force of gravity. So this is just 0.04 times 9.8. And if we punch this into the calculator real quick, 0.04 times 9.8, and we get 0.392. 0.392 newtons. So A and B, very easy. Just punch it into the equations. No big deal. Let's move it on down. So now let's go take a look at C and what they want for C. So let's go look at the problem again. What is the tension of the string at the top of the swing? So this is, you should have watched that whole video where I went through free body diagrams for top and bottom of the different scenarios. So this is the top for a stopper on a string. Is that a ball on a string, or is that a Ferris wheel? Hopefully you didn't have to think too hard. That's a ball on a string. So on a ball on a string, we're going to have a force of gravity down, and we're going to have a tension down. So what we're supposed to do is figure out what this tension is. Well, believe it or not, this is real easy. Because this force of gravity is 0.392. We know that because we just calculated it. The other thing we know is that this whole thing is the centripetal force. That's the net force. And we know that this has to equal 0.625 newtons. Don't put units over there. So basically what I got to do is figure out what plus 0.392 equals 0.625. So if I just go to the calculator real quick, and 0.625 minus 0.392, we get 0.233 newtons. All right, we're done with part C. So there's our answer for part C. Let's scroll on down some more, and let's talk about part D. All right, let's go look at the problem. I believe this is the bottom of the swing. Let's just double check. Yes, what is the tension in the string at the bottom of the swing? Okay, so here we go back to our problem. Now, if you recall, they all look the same because we have our force of gravity down and we have our normal force up, or in this case, the tension is up. And so that would be our centripetal acceleration right there. But what we do know is that FC, our centripetal force, is equal to 0.625. And not only that, but that's equal to the force of gravity plus the tension. And we know now that this force of gravity should be negative because it's pointing away from the center of the circle where the tension is positive. So now we just get 0.625 is equal to a negative 0.392 now, plus whatever the tension is. So we just solve for the tension real fast, and the tension comes out to be 1.02 after we round. So 1.02 newtons. Okay. So not too difficult there. Drawing some simple free body diagrams. Again, this is why it's so important that you watch the previous video where we went through all of the different types of scenarios on a free body diagram, on Ferris wheels, and ball on a string. Okay, now back to the problem though. Now we want number 2. It's a 40-gram stopper. Is twirled on a 40-centimeter string in a vertical circle. Okay. What speed must the stopper be twirled so that it will feel weightless at the top of the circle? So this is the weightless stuff that I was talking about on one of the other videos that, again, you should have already watched. So let's go down again. So let's scroll down. So this is number 2. It's the same stopper, same string, but now for it to feel weightless, if you recall, there cannot be a tension. What's that tension got to be? That tension's got to be 0. So it can't be there. We can't feel any other force. So the force of gravity is the only force acting. That means that the centripetal force must be equal to the force of gravity. Well, you already calculated the force of gravity. You know that's 0.392 from the previous problem because everything's the same. And then you know that the centripetal force is equal to the mass times the centripetal acceleration. All right. And so you know what I'm going to do here real quick is I'm actually going to solve this all in variables. So I'm going to just, I'm going to erase this and just go ahead and say, force of gravity is equal to mg. I'm going to divide by m and divide by m. So I get AC is equal to G. And if we remember, this is V squared over R is equal to G. So if we just keep going and solve for V, multiply both sides by R. That's an R, not a V. And then we're going to have to square root that. So V is going to be equal to the square root of G times R. And so now we just plug this into the equation. That's 9.8 times my 0.4. Again, that's the radius from the previous problem. That's why I know what that is off the top of my head like that. And so we get 9.8 times 0.4 equals, and then we need to square root that. And I get a velocity of 1.98 meters per second. Okay. Now, if we go back to the problem, so it's 1.98 meters per second. At this speed, what is the tension in the string at the top of the circle? Well, remember, it is 0. So that's the answer to A. The answer to A is it's 0. There is no tension at the top of the circle because we can't feel that force. Now, at this speed, what is the tension in the string at the bottom of the circle? All right. Well, if we go back and look at, if you remember from the previous videos, you know that it should be double. Okay. So if you're thinking about that, this should be 3.96. Or excuse me. No, that's incorrect. The tension should be double the force of gravity. That's what I was trying to say. I'm sorry. And so we should get 0.784 for the tension. Well, let's say you don't remember that. Let's say we actually need to calculate it. So let's go calculate it. Okay. So this would be part B here. Okay. We know the velocity is 1.98 meters per second because we just calculated that. So at the bottom of the circle, we'd have our force gravity out. We'd have our tension in. Okay. And we need to figure out what the tension is equal to. So if we do this real quick, we'll just say that FC is going to be equal to FG plus tension. We know that FC is mv squared over r, and FG we've already calculated, so I'm just going to say 0.392 plus the tension. And so this will be 0.04 times 1.98 squared, that's a 4, all over 0.4 is the radius, is equal to 0.392 plus t. So now we're just going to solve for t. So when we do that, oh, hold on before I get going too crazy here. Force of gravity is negative. So that's negative. That's negative. Better catch myself there. So 0.04 times 1.98 squared divided by 0.4. And we add the 0.392 over. And lo and behold, we get exactly what we predicted, 0.784 newtons. Okay. Now let's go back and look at the problem again. For part C here, what does this speed represent? A minimum or a maximum speed for the twirling stopper? This is a minimum. If we go any slower, it can't maintain uniform circular motion. It becomes a smaller circle. So we have to consider this as a minimum. What will happen if the speed of the stopper is increased? All that will happen there is the tension in the string will go up. All right, that's all that happens there for part one. And number two, what will happen if the speed of the stopper is decreased? The stopper will just continue into the radius will become smaller. It'll still be a circle. It'll just change the size of the radius. It does not become uniform circular motion anymore because now it's changing its radius. So the radius just gets smaller. All right. So there's number 1 and 2. Come back for the video on number 3.